I'm Shubhra. I run product marketing and developer relations at Joint. And I'll be joined by quite a few developers. Wyatt, show of hands. Wyatt is my colleague. He's a lead Node.js engineer. And he has been an active contributor to different frameworks like Happy, Seneca, and even for the Node microservices that we run ourselves at Joint. And even myself, I've been in the Express community, and I've worked on frameworks like Loopback and API gateways. Right? So just to give you a context. So the workshop today is going to be focused on building an IoT app, and we'll be using a variety of technologies. I'll walk you through that stack. But before I do that, want to put a disclaimer. We are not going to be talking any proprietary or closed source products. At Joint ourselves, we have been the progenitor of Node. We are kind of the first to incubate Node.js, and we are also the founding member of CNCF. And we believe that the entire cloud and all the technologies running within it should be in the open, right? And we are entirely community-driven. So with that, I want to give you our point of view on how we see the legacy stack and the modern stack. And this is based on people we are working in the community, our customers as well. So if you look at the legacy stack, right, these were traditionally monolithic web apps, and we're running code on different kind of blocking and bloated platforms, right? You could say JVM, CLRs, what they were. And traditionally, these were deployed in virtual machines, right, if you go back like 10 years, and running inside a private data center. Now, if you flip the stack, like when you talk about modernization, the app services are more message-driven. There are more microservices. They are built for mobile first, right? You don't really build for, they are build responsive. They're not just built for the web. You're building them for IoT workloads as well as artificial intelligence workloads, right? And we can go into depth. I'm just gonna skim through a lot of these topics. From a coding perspective, you'll see the rise of Node.js, Golang, and a lot of different lightweight runtime platforms or languages. The whole idea is, like, can you support concurrency? Can they work with async workloads, right? And from a runtime perspective, if you take the case of microservices, there's a perfect fit where you want to run them on containers. If you take the case instance of Node.js, most of the processes are running single-threaded. Running them on a traditional VM is probably an overkill. So you probably want to just package it, run it, package it in an immutable fashion, push it to the cloud, run it on a lightweight container, right? And the infrastructure supporting that is, that's kind of, I don't have to preach on that. That's essentially cloud right now. But there are differences in the cloud, right? So some of the projects we work on, and we'll be discussing these in the framework of this workshop. If you look at Node, we work on Node Core, Restify. Restify is a framework. Dtrace is essentially a universal debugging tool that you can use in production. Happy, is another API framework. MDB was, again, for memory leak debugging. We're also going to talk about Express Gateway, which was recently launched, as recent as last week. And again, we have been investing. We are polyglot ourselves. We are not a 100% Node shop. So if you look at tooling and live projects that we are working, and particularly in the Golang community, these are around Terraform, around, particularly for provisioning our containers, for console, for service management, Vault for security, Prometheus for monitoring, Packer and Crypto and other core libraries. And on the container side, we started with containers 10 years back, right? We were running infrastructure of bare metal containers, and then we ported Docker, but we had to make it run in production, not like a Mickey Mouse like standalone project. So we created the concept of an elastic Docker host, where we abstract the entire data center into a single Docker host with a single Docker API endpoint. And you can just push, based on a compose file or any artifact you have, you can essentially push your application blueprint and get it deployed in a matter of minutes. And obviously, we work on Kubernetes, and we have also created a micro app orchestration framework called as Container Pilot. We are going to be using Container Pilot today, right? And finally, on the cloud, obviously, because our entire cloud is 100% open source, we operate our public clouds, but most of our users also deploy it on premises in their own private cloud, managed private cloud settings, and it's primarily due to cost and performance. So let's go into the details. So there's a GitHub link. If you want to grab that URL, I'll be on this slide for a few seconds. That has all the contents of the code and the exercises. So it's github.com/joint/summit workshop. Just a show of hands if anybody was not able to get that. All right, perfect. There are some prerequisites. For this workshop, we'll primarily be using Node.js. So you'll have to install Node.js if you haven't already. You should. And you can do that like when I'm walking through the rest of the slides. You need to at least have a local Docker install. I think those are the primary prereqs. And optional, if you really want to push this out, like once you test it on your laptop, if you want to push this out into a public cloud, you can essentially sign up for Joint's public cloud. We have $250 free credits, and we won't be charging anything for the workshop, right? But again, that's optional if you really want to test it out, like how it works in the cloud. Make sense? So I'll just hang on to this slide for another few seconds so that you have the URLs. Perfect. All right, so what are we going to build today? We are going to build an IoT app, and it's a highly distributed microservice app. We'll have a variety of endpoints that we'll consume data from. So, we'll be using sensor data, and out of the sensor data, we'll be using a home automation platform called as SmartThings. And SmartThings, sells you sensors for, motion sensors, humidity sensors, whatnot. And once we get all that data, we'll be monitoring the data feed that is coming in. We'll be storing that into a database. That's where we'll use InfluxDB. And we'll also gather some monitoring data for using agents like Prometheus. And then we have a variety of other components, including an API gateway, including Redis. And then all of these services that are interconnected with each other, each of them is running on a container of its own. And we will orchestrate this, and we will scale it out, right? So we'll start from scratch, build, test, integrate, deploy, and scale, okay? So just few of the technology stacks that we'll be covering today, right? If you want to take a picture, you could. So at the very top, right, because we are consuming data from a SmartThings sensor, and we are not going to use real SmartThings, we are going to simulate that data, right? But it's kind of the same experience if you had to get it from a real home automation system, right? To protect all these APIs, we are going to use a front-end component called as the Express Gateway. And I'll get into the details of that. This project was launched last week, and we have Irfan from the Gateway team. Just raise your hands. So, if you have follow-up questions, you can reach out to him on the Express Gateway. We also have Al Sang from the Express Gateway team. So, they are here to help. And again, with me, I have Wyatt, and we have Colin. His hands, and we have Fires as well. So if you have any Node questions or container questions, reach out. Obviously, we'll use Node. We'll be using frameworks like Happy and Seneca. Seneca is a microservices framework, all written in Node.js. From a backend perspective, like from the front end, essentially we have Prometheus endpoints, and on the backend, we'll be using InfluxDB to store time series data. And from a container perspective, we'll be running traditional Docker. However, to wire our entire application blueprint and to deploy it and scale it, we'll be using Container Pilot. And finally, the option where we push it to the public cloud, we'll be using Triton from Joint. So when I get into all of these, let's quickly run through some of these key concepts, right? I just showed you a bunch of technology, and then we'll start really working the exercises. So just architecturally, how is SmartThings laid out, right? So it has a bunch of sensors, and every IoT home device manufacturer, this is not like industrial IoT. This is really home automation. You have a hub, right? And the traditional way these connects, there are a variety of protocols. There are Zigbee protocols and whatnot, where all of these devices that are present at your home, they connect to a hub, right? And based on those connection endpoints, then you essentially have device handlers, and then you send up the data through an API gateway, and that API gateway is consuming your events data and pushing it to a cloud processing system. And on the cloud side, and this cloud could be running anywhere, traditionally it's a public cloud, you have a set of core APIs which let you not just monitor the data, but if you have to take actions on your devices, like, hey, I have a thermostat which is reporting 75-degree Fahrenheit, and I have to control it down, I have to push it down to like 70. Or maybe I have like a Philips Hue bulb, right, which I want to dim. So there is an action that you need to take, and that API call comes through an API gateway, and then the API gateway communicates the same to your local hub, which is sitting at the edge, and then the edge hub translates the protocol and then sends out the control logic to the device that you want to control, right? So this is a very high-level architecture. So that's one component that we are going to use. The second component is we talked about the Express gateway. So show of hands, who has used Express.js? Pretty much everyone, right? So brand new gateway. It's an API gateway which was built on top of Express, was launched at a meetup last week, and highly successful, and like all the core contributors of Express, like Doug Wilson and everybody is behind it. Even from a joint perspective, we have started pushing PRs and we are actively contributing to it, right? And you have Al's company, Lunch Badger, who is kind of the core maintainer. And net, if you're really looking at what does the gateway do, right? You have a set of endpoints that you are protecting. So there are functions like authentication, authorization, right? You use a variety of tokens, and then you have to configure policies, right? So when the APIs come in, you define a set of policies which are applied on the pipeline of API calls coming in. And if you start going beyond that, then you have to really talk about role-based access control. Like, on these APIs, what kind of permissioning you have, right? Is it read, write, update, all the CRUD permissions? And then when you start going beyond that, then you go around metering, right? So if you're putting an API gateway in front of your API service, you can actually meter the calls. And you can extend this to chargeback. You can extend it to throttle, right? Saying, hey, you know what? This is one public API endpoint, and I don't want all of these internet population hitting this endpoint. Maybe I can create another load balanced one, right? So you can check this out. I'll not go into a lot of details into this because we have a lot of ground to cover. But this is one of the key components that we'll be using. Microservices, we are here to build microservices. Just show of hands, who has built a microservice running in production? Okay, a few of them. So, I don't need to be preaching to the choir, but essentially, this is a very simple visual representation of what I said earlier. You had a set of monolithic services. I have written monolithic services myself, traditional SOA architectures where you had an orchestration bus, and you had, endpoints, right? These were essentially web service calls that you were making. But again, they were they were packaged. They were not essentially like, you didn't have a particular service endpoint for a particular small API call where you could just manage the whole life cycle. So if that endpoint went down, right, you didn't really, you couldn't just work on it and bring that back again. You essentially had to work, recovering the entire SOA tier, right? So these microservices, right now the way you build it, there are different variety of frameworks out there. But once you start scaling these microservices, particularly on the container platforms, there are frameworks like Kubernetes. Any Kubernetes users here? This one. Okay, so there are frameworks. Kubernetes came out of Google. There's Docker Swarm. There's Mesos, where you essentially can orchestrate, right? How you deploy these and how do you scale these on containers, right? And this is a brand new stack, right? It's not on VMs. And these containers, you could be scaling, but it's not just scaling horizontally. You have to account for what happens if around managing the life cycle of a microservice. So we'll talk about that in a bit. So this is a layout of our own cloud. So Joint's entire cloud is built in microservices. We did it like 8 years back. when nobody knew the term microservices. We were built on Ruby on Rails. So all of the ones that you see in green, right, whether it's actually at our external endpoint, whether it's in our middleware, our internal services, or when we actually go ahead and access data, we have object storage at the back end. All of these are a set of APIs. And each API is managed by a standalone developer and a standalone team who can essentially manage the lifecycle and all the way from development to build to deploy to scale and everything else, right? And we chose Node.js, and that was one of our primary drivers why we contributed and sponsored the project to use something for ourselves. And then it caught on in the community, and now it's in the foundation. Makes sense? Cool. Another thing that's really coming to Forte is going container native, right? So if you deploy containers on traditional VMs, right, it's really a workaround. That's not how containers were designed to run, and that's not what will give you the efficiency of containers, right? So the stack that you see on the left is traditionally what most enterprises are doing today, whether it's on-prem or it's in the public clouds. And the reason is there was a lot of technical debt. You had created your data centers and your clouds based on VMs, and you couldn't really run containers directly on bare metal. You could, but on static bare metal, but then you didn't have the flexibility of like how do you do cloud management and scheduling and all those features, right? If you really start going into container native, not just us, there are other companies who are doing this as well. Instead of doing hardware virtualization using KVMs, we are going to doing OS virtualizations. So we are essentially running a Docker shim very close to the kernel, and we don't need any of the bin packaging libraries or any of the overhead that you need for VMs. And we are running the app, the Docker app directly on that. Cool. Another project that we are going to use today is the framework called as Container Pilot. This is, you can works with any scheduler if you're using Swarm, Kubernetes, or Triton, or Mesos. But this lets you do micro-orchestration. So I'll tell you what that means. So when you, create a bunch of microservices, it's not just start and stop, right? And particularly when you are running these microservices in containers, how do you manage the lifecycle events? So do you have, health checks going into a microservice? How do you, when there is an event, maybe there is a error, or, how do you handle that error? How do you gracefully start it up, and how do you gracefully stop it? How do you understand the events when, that particular microservice is choking and you need to provision more and scale out, right? So here's a very simple example. With MySQL, right? It's a relational database. You would be using this in most projects, very, very widely used. However, like in production, you don't want to be running one instance, right? You want to be continuously snapshotting your data and backing it up to some kind of an general object storage. So in this case, what we are doing is we have one primary node and two replica nodes, and we are continuously backing that data from the primary node to our Manta, which is essentially our object storage solution, and you could do this on any cloud in S3. But then those replica nodes, we do async replication, right? And you can set this up on your own. And on what we are doing is console, we are using it as a service discovery tool, right? So when a client comes in and it goes to query, it doesn't really go directly to the node. It goes and queries console and says, hey, console. By the way, if you don't know console, it's a tool from HashiCorp. Similar tools are like etcd, where you would use them in service management. But console will say, hey, I have these 3 endpoints, which are like all MySQL. This one is the primary, let's route the traffic there, right? So where you can see here that the call comes to from console to the primary, and you're doing heartbeats. So you're checking, hey, primary, are you up and kicking, right? And as long as that's true, the traffic will be routed there. Now, let's assume that the primary goes down, right? And at that time, you have a boot sequence which says, hey, boot from replica. But when that boot from replica happens, console needs to be updated automatically, saying, hey, now reroute the traffic and get the data from the replica set. And then I have to make those replicas aware and pooling, hey, has the primary come back again, right? So to do this, you can use, this is an entire pattern that has been created for application level micro-orchestration. So this one essentially is doing monitoring, right? So the way we work is there are different type of events. There's a periodic health check, but you essentially, whenever you provision a microservice, you register the microservice. So there's a registration event. You register that into console. And during the health checks, you are saying, hey, are you the primary? Yes, I am. Should I just back up my data? I said, no, I'm still in processing transactions, don't do it. Or yeah, maybe go ahead and do it. And continuously tell, I'm healthy, I'm healthy, I'm healthy. Now, if something goes down, the system has to self-heal, right? All these microservices should be self-healing because there are going to be thousands of microservices when you eventually go into the enterprise. You cannot do manual type processing like you do it for traditional SOA-based services. So what you could do is, on that event that you see, hey, there was a change, right? And on the change, what we said, okay, if the primary sent me a change event, maybe it went down. First thing you do is stop replication. Right? Don't replicate anymore because I'll be sending corrupt data into my backup. And at that time, look at me, I'm the primary, right? Or should I just give up my lock, or should I still retain my lock? So, well, you are down, so let the replica attain the lock and let that serve up, right? And now if I'm saying, okay, I'm back up again, go ahead and retake the lock, right? But when you do this, you have to propagate the changes upstream to your load balancer and to your service catalog. So when we actually use this in context of the code that you're going to write today, you'll see this, how helpful it is and how simple it's going to manage. So with that being said, I'm going to turn it over to Wyatt to walk you through the exercises. And I'm assuming by this time you have Node and a local copy of Docker installed. Anybody who has not been successful doing that yet? Okay, and we are here to help, so we'll be walking around the floor.
Thank you, Shubhra. Let me plug in here. So you all have you cloned the repo? Cool. So if you look on the README, let me turn this. Let me load this up. If you look on the README, it lists the different challenges. The first two are really geared to make sure that you have Node installed correctly, and then the second one is for Docker. So I think we'll probably spend about 5 minutes on each of those first exercises. So if you look at the README, we're just trying to spin up a simple Node application. So the challenge is to start it with a port, and in this case, port 8080, which will be provided through an environment variable. And once you have that up and running, you'll be able to go to your browser and see a chart with random data being displayed. And if you have any questions, feel free to raise your hand, and we'll bring over a mic, or just one of us will come and help you out. There's also a solution file in each of the challenges that explains the solution. So the pace of this will go, we'll spend 5 minutes on this first one, and then I'll show you the solution, and then we'll go to the next challenge, and so forth. But we want to keep this pretty laid back, so again, just raise your hand if you have a question or if you get stuck. So I'm going to go ahead and walk through the solution to the first one. It's OK if you didn't complete it, because the remainder of the exercises are all using Docker. That was more of a test to make sure you have Node installed and know how environment variables work. So let's see here. If I go into, I'm going to make that larger for you. If I go into the challenge 1 folder, so I have my, let's see, how did I set that up? So I had already npm installed everything before I came here, so I have that shortcut for me. And then you can set environment variables just by prepending whatever you want before you run Node. So in this case, I'm going to listen on port 8080. And if you go into your browser, you'll see, let's see, localhost 8080. You should see a front end with this random sensor data. And this is pretty much what we're going to see throughout the remainder of the exercises. So while this will actually work with a SmartThings hub, we don't have a SmartThings hub here, especially for this many attendees. And also, the sensor data from the real temperature data is kind of boring. This is a little bit more exciting, at least. So anyway, that's the solution to the first challenge. npm install, and then start Node. So the next challenge is using Docker, which is a little bit more fun. So we want to, let's go back to the challenge here. So the next one, we're going to Dockerize that front end. So this is just using that same front end that we had, running it inside of a Docker container, and listening on a port again. This will hopefully prove that you have Docker installed correctly. So again, we'll give you, say, 5 minutes to work through challenge 2, and then I'll present the solution. And if you get stuck, just raise your hand. How's everybody doing with that challenge? Is the network any better? No? Well, once you get that Node Alpine image, that should speed up the next challenge, hopefully. So anyway, let's walk through the solution here for challenge 2. So you're supposed to update the Docker file. So in this case, we're building from an Alpine distro of Node, which is actually the smallest one that you can find. So I did that hoping that the network wouldn't be this slow, but apparently it is. So typically with your Docker file in Node, you're going to copy over all your resources, so your package, your JS files, and then you'll need to run npm install. So if you look in the solution here, send a copy from that. So we'll run npm install, and you can see above this, we had already established that the working directory is where our app was copied to. And then I'm just going to run node period or node index or npm start, however you want to start up your node process. So that'll create the image that we need. But we also needed the port for the environment variable. And that comes whenever we're actually, let me get into the right folder. And that comes whenever we're actually starting the container. So I'll build the image, which is super fast because I already have everything downloaded. It'll be cached. And then you can run that image as a container. So I'm going to set the environment variable with that -e. And -p is publish. So I'm going to map the Docker host port 8080 externally. And then I'm going to give it a friendly name, front end. So that is now running. If I run docker ps, I can see. So I have that image running, and port 8080 is mapped. So again, if I go to localhost 8080, I should see the same front end that I saw whenever I had just Node running locally. OK, so also in the solution, it includes how to remove that. So if you do docker rm, that removes a container. If you want to remove an image, it's rmi. So docker rm, remove the front end. So that's great, pretty simple. Hopefully, you all didn't get too stuck on the Docker part. So let's move on to challenge 3, where we're actually adding another container into the mix. And for that, we're going to use Docker Compose. And we're also going to add in the Express Gateway, which we've been talking about. So the challenge here is to add, to update the Express Gateway configuration to point to the 2 instances of the front end that we now have in the Compose file. So if you look in challenge 3, Docker Compose, you can see that we are creating 2 front ends by having 2 different services, front end 1 and front end 2. So we need to update the links for the gateway so that it has the correct IP addresses mapped inside of the gateway that represent the front end 1 and front end 2. And then in gateway, we have this configuration YAML file that you'll need to update with the server and port for the front end 1 and front end 2. And since you're using links in this example, links will update the host file inside the container with like a front end 1 and then the IP of whatever that was started as. So I'll give you 5 minutes on this challenge, and then I'll walk through the solution. So you're going to use a different command also, Docker compose, instead of just Docker. Cool. All right. I'll let you get to it. And again, if you have any Express Gateway questions, we have a couple of experts here, so feel free to raise your hands. All right. I'm going to walk through the solution. Seems like things have sped up a little bit, which is good. So let's see. First, I'll update the links. So just add front end 1 and front end 2. So that'll add a new etc host entry for front end 1 with the IP address in the gateway container. And if I go into here, I can change the URLs. So the Express Gateway will load balance these two for me. So let's see, HTTP, and then the server will be front end 1, and then 8080. And then let's go into the right folder. Challenge 3. And then it'll, every time you refresh on 8080, it'll be load balanced to either the front end 1 or front end 2, and it'll just serve up either of those, whatever you get at the time. Also, I wanted to remind everybody that, well, I don't know if you were reminded of this at all, but there's t-shirts up here and stickers, popcorn. Come on up. Feel free to grab some. Yeah, you can come up anytime. We have all sizes, men's and women's. Help yourself. So, yeah, you have to at least have completed challenge 3 by now, though. So there you go.
The first one is women small, but then this is men small, medium, large, XL. What does it mean? Medium? The first slot is the women's. Yeah, and we have
Your size right now. We'll have more tomorrow at the Joyent booth out front. So come on by if you want a second shirt or whatever one that fits. So links is nice whenever you're doing local development, but when you're actually trying to scale to more than just a couple of instances, it's not really a sustainable solution. So as Shubhra was talking about earlier, we have Container Pilot, which takes out the issue of having to have a load balancer in between all of your services and relies on Console, which is a service discovery catalog. And we'll use that, we'll use Console to discover what services are up and healthy, and that's how we'll discover the front-end instances. So this next challenge is just to rely on the container pilot configuration to update the configuration. Let me show you that. Let's see. So if you look in the gateway folder, we have in Etsy, we have this JSON5 file, which is just this very JavaScript-friendly way to do JSON. It just looks like JavaScript. But anyway, this is how we control Container Pilot. So we describe what processes we want Container Pilot to start up. And in this case, it's the gateway. And since we're listening on a port, Container Pilot will register the gateway with console for us. And it'll start our server. So a good way to think about Container Pilot is just a really useful container init process. So you have like tiny and dumb init already that are made for running in containers for doing init work. Container Pilot is no different, except it adds in the extra service discovery and health checking that you'd want to have. So your challenge is to update the Container Pilot JSON5 file here to add in a job to run this binary, which gets copied, which generates and finds the front-end addresses for you. So yeah, and if you look in the README, there's also links for the Container Pilot documentation. But anyway, I'll give you, say, 10 minutes. But your main goal is just to add another job here, and then spin it up, and you should be able to go to port 8500 to see console, and you should also be able to scale the number of front-end instances you have to whatever number you want, and it'll automatically update the gateway, and the gateway will load balance everything for you. So 10 to 15 minutes, and feel free to raise your hand if you have any questions. So I'm going to go ahead and jump to the solution on challenge 4, mainly because challenge 5 is much larger and requires a few other images, and our internet is not the fastest, so let me go ahead and do that. So you were supposed to add in a new job to run the generate config for you whenever you're starting up. So you could do it just like this, which would work. But ideally, you would also add in this extra part, which tells the gateway not to even start until after I've been able to, until after this pre-start job is successful. So we won't even start the server until we actually have some front ends to balance too. And then we already had a watch down here. So anytime, so this last job, let me explain that, sorry. The last job will run anytime there's a change with the front end. So if there's a change in the front end inside of console, like you added more instances or one of them became unhealthy, then the gateway will be notified about that and will execute this onChange front end job, which will just regenerate the configuration for us, which was not entirely necessary for the challenge, but it's good to just have that kind of responsiveness built in. So if we start it all up, we should just have one instance of the front end. And let me show you. I don't know, did you all go to console here on port 8500? If you didn't, this is what it'll look like here when it loads. So we have console registered here, then the front end with two passing checks, and then the gateway. And we can go to the gateway, which is listening on port 8080. And we just have that one front end that's balanced. But you can also scale the front end to, say, 3 instances. So we'll create 2 more instances of the front end. And those, whenever they're healthy, will register inside of console. So if we refresh console here, you can see now we have 6 passing health checks for each of the instances. And then the gateway would have been notified that there's a change in console and reran that generate config, which went out to console and grabbed all the healthy addresses. So now if you refresh the front end, you should get balanced to another back end, and so on and so forth. So the next challenge really builds on this and adds the other services that we actually care about, so that the dummy data is not just coming from the front end, it's actually coming from a serializer, which pulls the data from a worker, which then pulls it from the SmartThings hub. So we'll just move on to challenge 5, which is a little bit more involved. Let's see, zoom out a little. So there's 2 parts to this. You're supposed to update the sensor. So if you look in the folder here for challenge 5, you now have, let's see, the front end, we have the serializer, and then the sensor, which is the worker that pulls data from NATS, which is a message queuing service, and pushes it to the serializer. So your job is to update, at the bottom here, we have this write data function. So use a module called piloted, which will talk to console for you, and we'll handle that change event automatically. So add in here something that uses piloted that pulls down the serializer address. And then also, you'll need to update the container pilot configuration for the sensor so that it has the on change for the serializer plugged into it. And since this involves a few more images, I think it's probably going to take another 20 minutes or so. But this challenge really encompasses, I think, a lot of what we're going for in the overall workshop. So I'm going to give you more time on that. And again, if you get stuck, feel free to raise your hand. Or if you just have any general questions, also raise your hand. So I realized I left you kind of hanging on what piloted is or why you'd even use it. Sorry about that. So piloted is just a module that will do the load balancing for you inside of your service. Since we don't have any load balancer that we're going through, we need some way to distribute our requests. And so piloted has a pretty simple API. You can do piloted.service and just the name of the service that you care to get. So in this case, the serializer. And it'll bring back the next healthy address for you for the serializer. So in this case, we'll do serializer equals that. So serializer in this case will have the address and port from console of the next healthy instance of the serializer, because we can scale to multiple instances now if we want. And the nice thing about this is we actually, since we don't have a load balancer, we can tell if there are any healthy serializers at all. So if there aren't any serializers, we can do what you're supposed to do in a microservice, which is be able to, respond to failure. So in this case, let's say we don't have any serializers. I could return early and maybe try this again in like a second. So I don't know, set timeout, and then write data. This is, of course, going to consume more memory, but it'll work. Yeah. Yeah. So that's the example there. I think that's right. So then the other part of the challenge, again, was just to update the container pilot config, which I'll leave you to that, and downloading the images. But any questions on piloted or why you'd use it? Or does that explain it? OK, cool. So I'll show you the rest of the solution in, say, 5 minutes. Does that sound good to everybody? I'm going to show you the solution to challenge 5 here, and then I'm going to go through the next 2 exercises since we're low on time and just show you those solutions as well, which builds on what we already have here. And then I'm going to hand it back over to Shubhra to close it out. So let's see. So we already have the serializer update done. And I was talking to Colin back there, and he was pointing out that this is probably not a good solution because it's going to buffer up the data in memory and eventually probably exhaust your memory. So since it is sensor data and you probably don't care about it so much, you could just return early and be done with it. The other part of this was to update the container pilot configuration so that it responds anytime there's a serializer change in console. And the way we do that, I'm just going to copy from the solution file. So we'll create another job. Let's go back. So we need to create another job similar to what we have here for NATs, which says anytime there's a change to the serializer, we're going to send a SIG-up signal to Node. And that'll not restart the process, but it'll just send that signal. And then piloted will handle it and go out and fetch an updated list of healthy addresses from console because something changed. And the other part was to add the actual watcher. So container pilot will use these watches to just query console for changes to serializer or NATs. So that allows us to, let me go to the right folder here. That allows us to spin up new instances of the serializer or tear them down, and the sensor will be able to handle those changes, which is very powerful. Okay, so we can do Docker compose up. Oh, I think I have my previous one still running. So kill everything. Bring it up with the all right, I'm gonna kill that. Challenge 4. So this is a good habit. Make sure you remove everything from the current challenge before moving on to the next one, which is what I failed to do there. So challenge 5, Docker compose up, -d. So there's quite a few more images in this one. We have influx, NATs. If we go back to the front end, again, we can see, in this case, since we don't have all the workers running, we should just see the temperature data coming in. We'll wait for that to load. And also, if we look at console, now we have more services that are registered. So now we have SmartThings, NATs. So yeah, we have the temperature sensor done because we have that worker added. The next challenge would be to add the other workers, so humidity and motion. And the way you do that is to update the compose file. So if you look down here, we have temperature, which is using that sensors folder. So we can change this to humidity. So add a new service named humidity, and we just say the sensor type is humidity, and it'll start subscribing to the NATs message queue for any humidity messages. And it'll report those into the serializer. So if I do up again, since I just added humidity, give it a second here. Actually, let me go to the next challenge since it'll be cached. Let me bring it all down. So the next challenge would just add those two, and then you'd see the data flowing. But it's just essentially just copying and pasting from the Telemetry Docker Compose service here. So the last challenge, which is what I'm going to show now, is adding in telemetry reporting. So Container Pilot, in addition to using console for service discovery, also has telemetry support for Prometheus. So you can add in any metrics that you care to report on. So if you looked at challenge 7, say the front end, you should see there's like a memory script here, which will report on how much free memory is inside the front end container. And if you look at the configuration for that, we now have this telemetry entry. So this will listen for on port 9090, and Prometheus will know that there's telemetry data because we're registered inside of console. We have a new entry for Container Pilot. And then Prometheus goes out and pulls all these metrics down and will report on them. So I want to show what that looks like, which is actually pretty powerful, mainly because it's so flexible. Yeah, I'll just do that. So again, if you refresh console, you'll now see Prometheus whenever it comes along. So it might be the last to come up. And then Prometheus listens on port 9090. And then you have these custom metrics that we just added. So the free memory, you can report on that. And again, this is completely dependent on whatever you want to report through Prometheus. And then if you scaled out the front end, you would see more instances shown. So scale front end, say 2. And then if you refresh or execute that graph again, you'll see more metrics coming through for each instance. So that's what I have for the workshop. I know we didn't get through everything, but again, you can take this home and play around with it. All the code's there. Solutions are all there. And I also wanted to point out, so you can deploy this to Triton if you want in that final section. And we also have another working example of this. So if you go to GitHub/autopilot pattern, we have tons of examples of using Container Pilot for solving the same type of problem, but for other things like MySQL, as Shubhra was pointing out. We have Jenkins, we have WordPress, but we also have another Node example, which is very similar to this one, and it has a nice setup script and walks you through deploying everything to Triton if you want to. So that's what I have, and I'm going to hand it back over to Shubhra to close us out. And I'll be here throughout the week if you want to chat about any of these topics or anything else. Thank you.
All right, folks, I'm going to wrap this up. But that being said, I think you are working towards different exercises, and you have deployed it locally to your Docker environment. I'm going to try and give you a quick overview of how we have architected Triton, so that if you want to push it to a real cloud and run it for yourself, you can. So essentially, like when we build Triton, right, we build it as a next generation of cloud. And there are different ways you can run it, right? You can essentially build your own cloud your way with essentially open source software, right? So you can run it public, you can run it private, you can run different hybrid modes. But there are three key components to it, right? There is compute. And when we say compute, this is essentially containers on bare metal and different containers, like, I'll go through that. And then there is object storage. That project is called Manta. So if you go to GitHub, github.com/joint/Triton, that's essentially your compute. And if you go to storage or analytics, go to github.com/joint/Manta. Those two are the storage and converged analytics. And converged analytics is a special project because if you really think of it, right, generally when people store object data somewhere, and then you're running like big data jobs on that, you essentially have to copy data over the network. So whenever you are accounting for latency, you have to take into account the time it takes to move data over, and particularly if you're operating at petabyte, exabyte level scale, that's extremely time consuming. So I'll tell you a little bit more architecturally, but here's essentially a system architecture, like how you can build your own cloud, right? So at the very lower end, you see the infrastructure, which essentially is elastic bare metal. What this really means, it's OS level virtualization instead of hardware virtualization. And on top of it, you are either running elastic Docker host or you are running traditional VMs, right? And even VMs, we essentially use KVMs, so you can bring your own KVM. And then you can run any image on top, right? If you are really a Windows shop, you can run Windows on there. But if you're running Docker, you can run Docker directly on the elastic Docker host, or you can bring a scheduler like Kubernetes and make it work with that. And so there are three different ways to run containers, right? So it's not like, when you start speaking with other developers and ask them, like, what are you using to run microservices and containers? Like, how do you decide? The first one that you see here, Kubernetes, I've asked that in like DevOps conferences, and show of hands, like who's using Kubernetes, and 80% of them raised their hands. And I said, like, why? Right? Oh, because my coworker told me to. Right? You really need to take a pragmatic approach and say, hey, what are the use cases behind it, right? If you are building a microservices application, just like you were building now, and you had a few endpoints, right? How many endpoints did you have? Like 10, 12? Those were the REST API endpoints. Start thinking about a large enterprise and a larger scale application where maybe you have 1,000 endpoints. And each of those endpoints need to run on a container each, right? And you need to orchestrate them at real time. For that kind of a heavy lifting, I would think Kubernetes type of a framework is a great fit. But if you really want to run one container, right, having a small monolithic app, or maybe 10 containers, I think it's simply an overkill, right? Or maybe you want to run stateful apps, right, databases, or wherever you are caring about transient state and persistence. I don't think Kubernetes has yet nailed that. Right? So that's where we kind of went category by category, right? So we created elastic Docker host, which is essentially great for if you're running, you can run both stateful and stateless, but it's really, when you looked at container pilot, with some of the use cases we talked about with MySQL, we're essentially dealing with persistent state, right? Which you cannot do with a framework like Kubernetes. But if you really are really scratching the surface here, and all you really care about is cost savings and performance, you can just run bare metal, but with the cloud flexibility, right? So that's where we have brought in this concept of infrastructure containers. Has anybody heard the term infrastructure container before this, earlier? Just one guy. Yeah, so if you have to do a little bit of reading, right, go search up LXCs, right? LXC containers, or just pure infrastructure containers. This didn't, like Docker didn't, or containers didn't really arrive with Docker in 2013, 2014. People were doing containers like way back in 2006. And we originally used a project called Open Solaris, which was derived from Illumnos to build those, but then there are the Linux guys who have been using LXC containers to primarily achieve the same thing, right? You can have containers, run them just like a virtualized infrastructure, but you run them on bare metal without having to, take the overhead of all the hardware virtualization and the bin packaging, right? So another great project to look at, I talked about Manta when we get converged analytics. So you can really store data at scale. So Joint, like we got acquired by Samsung, and just as a use case, right, we are hosting all of Samsung Mobile's backend data. And if you have to get some context, how big that data looks like, it's in exabytes a year, right? Think about 250 million concurrent users pushing images, videos, whatnot to their phones, and we are essentially tasking ourselves to handle that data, right? So on a highly distributed open source object storage system. So that's object storage. But what we have done is a few years back, when we ran this on a file system, we used ZFS as the underlying file system, and we were able to spin up a container in place where the object data resided. So when you spin up a container, what you can actually do with it is run a compute job, right? So hey, I want to run a big data analytics, right? So let's say I have a MapReduce job I want to run. Or maybe I want to do log processing or search text, right? Just query the data. How do I do that, right? So if you just want to transcode the data, hey, I had these image files, I want to create thumbnails of that, or run any kind of arbitrary compute. So because we spun up that container zone, right where the object data was, you can essentially run converged analytics without having to move the data anywhere. And when we did this, we essentially followed the Unix Bible and said, hey, if you run Unix commands, you can write your own compute job. You don't really have to learn a framework. You could write your own compute job in awk, right, in Perl or Shell or any other language. You can bring other languages, but it's not framework dependent, right? And so I would highly encourage you to go to GitHub, check that out, github.com/joint/manta. And net, right, like with all these projects, what we are really trying to build at the end of the day, and we have built it ourselves, we are trying to share this for the community, is essentially build open and portable services, right, which don't have to be locked into a particular framework, a particular cloud, or particular orchestration framework. So these are some of the sample projects that got built with Container Pilot. So Wyatt was just walking you through the GitHub repo, so check it out. It's actually very simple to build. Self-managing and self-healing application patterns using this microservices. And net, I want to end by saying, our goal is essentially to give the cloud back to the people and democratize the system. And that's why we are here. So, we'll be at the booth in the rest of the conference. Swing by our booth, talk to us. And, if you have not got any swag, feel free to grab them. I want to call out the Express Gateway guys one more time, Al Sang and Irfan, and thanks Colin and Wyatt and Faiz for showing up and helping. Thank you.